The big freighter that disappeared many years ago? That's the one. A meteor swarm struck her on the way to Venus. Furthermore, one of them shorted out her engine controls so that she swooped out of the ecliptic plane and fell into an eccentric skew orbit. When this project was first started, one of our astronomers thought he'd identified the swarm. It has a regular path of its own about the sun, though the orbit is so cockeyed that spaceships hardly ever see the things. Anyway, knowing the orbit of the meteors and that of the Waikiki at the time, he could calculate where the disaster must have taken place, which gave us a lead in searching for the hulk. We found it after a lot of investigation, moved it here, and built the station up around it. Very handy, and completely secret. Lancaster had always suspected that security was a little mad. Now he knew it. Oh well. His room was small and austere, but privacy was nice. The lab crew ate in a common refectory. Beyond the edge of their territory, great bulkheads blocked off 3/4 of the space station. Lancaster was sure that many people and several Martians lived there, for in the days that followed he saw any number of strangers appearing and disappearing in the region allowed him. Most of these were workmen of some kind or other, called in to help the lab crew as needed. But all of them were tight-lipped. They must have been cautioned not to speak to the guests more than was strictly necessary. Living was Spartan in the station. It rotated fast enough to give weight, but even on the outer skin that was only 1/2 Earth gravity. A couple of silent Martians prepared undistinguished meals and did housework in the quarters. There were no films or other organized recreation, though Lancaster was told that the forbidden sector included a good-sized room for athletics. But the crew he worked with didn't seem to mind. They had their own large collections of books and music wires, which they borrowed from each other. They played chess and poker with savage skill. Conversation was, at first, somewhat restrained in Lancaster's presence, and most of the humor had so little reference to things he knew that he couldn't follow it, but he became aware that they talked with more animation and intelligence than his friends on Earth. Manners were utterly informal, and it wasn't long before Lancaster was being addressed by his first name. But cooperation was smooth, and there seemed to be none of the intrigue and backbiting of a typical project crew. And the work filled their lives. Lancaster, caught up in the day after his arrival, realized at once what it meant, and was plugged into the fascination of it. Berg hadn't lied. This was big. The perfect dielectric. Such, at least, was the aim of the project. It was explained to Lancaster that one Dr. Sophoulis had first seen the possibilities and organized the research. It had gone ahead slowly, hampered by a lack of needed materials and expert personnel. When Sophoulis died, none of his assistants felt capable of carrying on the work at any decent rate of speed. They were all competent in their various specialties, but it takes more than training to do basic research. A certain inborn intuitive flair is needed. So they had sent to Earth for a new boss, Lancaster. The physicist scratched his head in puzzlement. It didn't seem right that something so important should have to take the leavings of technical personnel. Secrecy or not, the most competent men on Earth should have been tapped for this job, and they should have been given everything they needed to carry it through. Then he forgot his bewilderment in the clean, chill ecstasy of the work. Man had been hunting superior dielectrics for a long time now. It was more than a question of finding the perfect electrical insulator, though that would be handy too. What was really important was the sort of condensers made possible by a genuinely good dielectric material. Given that, you could do fantastic things in electronics. Most significant of all was the matter of energy storage. If you could store large amounts of electricity in an accumulator of small volume, without appreciable leakage loss, you could build generators designed to handle average rather than peak loads. With resultant savings in cost, you could build electric motors containing their own energy supply and hence portable, which meant electric automobiles and possibly aircraft. You could use inconveniently located power sources, such as remote waterfalls, or dilute sources like sunlight to augment, maybe eventually replace, the waning reserves of fuel and fissionable materials. You could... Lancaster's mind gave up on all the possibilities opening before him and settled down to the immediate task at hand. "The original mineral was found on Venus in the Gorbu Vashtar country," explained Karen Marek. "Here's a sample." She gave him a lump of rough, dense material which glittered in hard rainbow points of light. It was just a curiosity at first, till somebody thought to test its electrical properties. Those were slightly fantastic. We have all chemical and physical data on this stuff already, of course, as well as an excellent idea of its crystal structure. It's a funny mixture of barium and titanium compounds with some rare earths and, well, read the report for yourself. Lancaster's eyes skimmed down the sheaf of papers she handed him. "Can't make very good condensers out of this," he objected. "Too brittle, and look how the properties vary with temperature. A practical dielectric has to be stable in every way, at least over the range of conditions you intend to use it in." She nodded. "Of course. Anyway, the mineral is very rare on Venus, and you know how tough it is to search for anything in Gorbu Vashtar. What's important is the lead it gave Sophoulis. You see, the dielectric constant of this material isn't constant at all. It increases with applied voltage. Look at this curve here." Lancaster whistled. "What the devil? But that's impossible. That much variability means a crystal structure which is, flexible, damn it. But you've got a brittle substance here." According to the accepted theory of dielectricity, this couldn't be. Lancaster realized with a thumping behind his veins that the theory would have to be modified. Rather, this was an altogether different phenomenon from normal insulation. He supposed some geological freak had formed the mineral. Venus was a strange planet anyway, but that didn't matter. The important thing now was to get to know this process. He went off into a happy mist of quantum mechanics, oscillation theory, and periodic functions of a complex variable. Karen and Isaacson exchanged a slow smile. Sophoulis and his people had done heroic work under adverse conditions. A tentative theory of the mechanism involved had already been formulated, and the search had started for a means to duplicate the super dielectricity in materials otherwise more suitable to man's needs. But as he grew familiar with the place and the job, Lancaster wondered just how adverse the conditions really were. True, the equipment was old and cranky, much of it haywired together, much of it invented from scratch. But Rakan the Martian, for all his lack of formal education, was unbelievably clever where it came to making apparatus and making it behave. And Fredericks was a top-flight designer. The lab had what it needed. Wasn't that enough? The rest of Lancaster's crew were equally good. The Dufreres were physical chemists par excellence. Isaacson, a brilliant crystallographer with an unusual brain for mathematics. Huang, an expert on quantum theory and interatomic forces. Karen, an imaginative experimenter. None of them quite had the synthesizing mentality needed for an overall picture and a forevision of the general direction of work. That had been Sophoulis' share, and was now Lancaster's. But they were all cheerful and skilled where it came to detail work, and could often make suggestions in a theoretical line. Then, too, there was no security snooping about, no petty scramble for recognition and promotion, no red tape. What was more important, Lancaster began to realize, was the personal nature of the whole affair. In a project, the overall chief set the pattern, and it was followed by his subordinates with increasingly less latitude as you worked down through the lower ranks. You did what you were told, produced results, or else, and kept your mouth shut outside your own sector of the project. You had only the vaguest idea of what actually was being created, and why, and how it fitted into the broad scheme of society. Huang and Rakan commented on that one evening at dinner when they had grown more relaxed in Lancaster's presence. "It was inevitable, I suppose, that scientific research should become corporate," said the Chinese. "So much equipment was needed, and so many specialties had to be coordinated, that the solitary genius with only a few assistants hadn't a chance. Nevertheless, it's a pity. It's destroyed initiative in many promising young men. The top man is no longer a scientist at all. He's an administrator with some technical background. The lower ranks do have to exercise ingenuity, yes, but only along the lines they are ordered to follow. If some interesting sideline crops up, they can't investigate it. All they can do is submit a memorandum